Eric Larson back again with you. And when we left off, we were talking about shear walls and the standard normal wall nailing pattern. So I wanted to jump back to my generic wall and show you an example of what that standard nailing pattern actually looks like in more detail. So here's the generic wall, and I've turned off the visibility on all of the pieces of sheathing except for the first one. And if we turn on this drawing which I've made here, which shows the nailing pattern, and zoom in on it a little closer, this is what a standard wall nailing pattern looks like for a wall that is not a shear wall. And this is not very complicated. You simply put a nail in every 6 inches, and you can go 12 inches down the center, and you got your nails in every 6 inches. It's not very difficult. Now if you're nailing on a wall or on a piece of OSB where there's a double stud, the nails can go more or less straight in. If you're nailing on a wall or on a piece of sheetrock where two studs or two pieces of OSB need to both go into a single stud, then you need to put the nails in a little bit of an angle to make sure that they hit that stud in the center. Okay, well that's the standard nailing pattern. Pretty simple. Okay, so we can talk about the details of each of the walls in the building. I'm not going to go into a great deal of detail. I'm going to kind of rip through this. But we've got the party walls, which are in the center. We've got the rear wall, it's the back of the building, side wall along the side, the front wall, which is the front of the building. The mini wall is the short wall that kind of where the walls sort of take a little jog, and the door wall is where the door is. It's pretty easy. So we can pop back into Fusion. So here we are back in Fusion, and we can zoom in a little bit, and let's start with our focus on the rear wall. Obviously, it's not a drastically complicated wall. It's got a window, a big window. It's got a small window for the bathroom. It's got a door opening. If we look here, this is what the wall looks like in isolation. One of the first things you'll notice is it's got these door trimmers that come down below the bottom of the bottom plate. Now, when you actually build this wall, what you want to do is you want to have the bottom plate be continuous, and you want to leave those door trimmers off. And then once the wall is raised, you cut away this part of the wall and put your door trimmers in. At least that's my idea. That's how I would do it. You might get some different opinions from whoever is actually leading the building. But we can turn off the visibility of each of these OSB sheets. And one of the things that you'll notice about this building is that all the sheets are rectangular. Now, when I first got started with this, I kind of made some L-shaped sheets, but Jared said, nope, we want all the sheets to be rectangular. That way we can cut them out easier and slap them in there. So that's what we got. And it's not a drastically complicated wall. You can see that we've got 3 studs side by side here near the door. It's going to be super strong. You got 3 studs side by side at the window enclosures, and again, 3 studs side by side. Now you've got a 4x6 on the corner. So this building is going to be astoundingly strong. Trust me, it's built for hurricane weather. So here's a typical drawing that you have a drawing which is very similar to this for every single wall in the building. You've got fully fleshed out layout dimensions that show you where each stud needs to go. the bottom plate's labeled, the top plate's labeled. This wall has a 3x6 bottom plate. You want to read these notes, which are generally in the lower left corner of the drawing. What you will see, what the notes for this wall say, is that the bottom plate is 3x6. It's borate treated. It does not require galvanized nails. Now, that's a little bit different from all the treated lumber that we've ever dealt with before, in that we were required to use galvanized nails. But we've got a new type of lumber. It's borate treated, so you can use regular nails with it. It's very advantageous that we don't have to manage a whole lot of different kinds of nails. You know, if you're trying to keep track of the galvanized nails and regular nails, if you can just use regular nails, it's a lot simpler. So anyway, we've got the the window rough opening here. It's labeled 63 by 46.5, and you've got a real small bathroom window. What's cool about this window is that it fits right between a standard stud bay. So a standard stud bay is 22.5. Pretty simple. Okay, this is a standard wall, standard framing diagram. Okay, we don't want to save that. Okay, and we can just kind of go around and look at each wall. This side wall here, this should be one of the simplest walls that we build. It's got four standard sheets side by side. Got two windows. If we go around to the front, we can see that the front door wall is pretty simple. It's the top and bottom, or the top floor and the first floor front walls should be very similar to each other. And you've got the front door wall. You know, that's a pretty simple wall. Not going to go into a great deal of detail on the walls, because they're very well specified with the drawings. You can read them. Okay, back to the slideshow. Talking about sheet materials. This is for sheathing of the building. OSB is what we use. It's called oriented strand board. It's typically 15-30 seconds, which is, you know, very close to 1/2 inch thick. It's like 1/2 inch plywood, but it's a lot cheaper. And you can make OSB, and you use more of the tree. You don't have to have a big, beautiful log that you peel off. You can simply use wood chips and stick them together. OSB is stronger than plywood in shear. It's also lighter. It's much easier to work with. So edge of each sheet of material needs to land on a stud. We kind of talked about that earlier. So sometimes we will use less than a full sheet of OSB. So corner alignment. So this pertains to what a corner of a wall looks like when you have two pieces of OSB that are meeting perpendicular. And we'll talk about a good corner, a bad corner, and an ugly corner. And an ugly corner is one that you don't like, but that you can live with. So we'll jump into a special part of the presentation I created for this. Okay, this is a special explanatory part of the video, which is about corner alignment. I'll try and rip through this. I kind of realized that I got into a little more detail than I really needed. But you got basically 6 different ways to align your corners. Corner example number 1, if we zoom in on it real closely, this is what you will get if you build a building exactly the way it was designed. And the two pieces of OSB will meet along this edge. There will be a slight gap here, an air gap, and you can put your trim. You can put your trim on the outside, and that's perfect. That's a good corner. Okay. Number 2 is also a good corner. And this is it might actually even be better because there's no gap, and the two sheets butt together and there's no gap. Number 3 is the same. It's just it's aligned slightly differently, but you can see your trim goes on the outside, no sweat. 4 is also a good corner. It's different from 3 in that you have a slightly different trim alignment. Now 5 is an example of what I would call an ugly corner because you've got a gap here, and this is what you might get if you have some sort of slapdash carpenters. But you can handle that, and as long as this gap is not too large, maybe that gap is only 1/8 of an inch. I would personally say that I could live with that, and it's perfectly good because your trim covers up that gap. But if you've got more than about 1/8, you may need to do something about it. And what you can do is simply cut a piece of sheet material that will slip in here, and that will work. But you need to consult with your site carpenters, consult with your experts. Your construction leaders will tell you what they think. Now 6 is an example of a bad corner. You can't put trim on a corner that is like this. And what you have to do is you have to rip this edge off. Get yourself a Sawzall and just rip it off, and then you can put your trim on. And in the process of cutting it away, you might make a sort of ugly looking corner, but that's fine. It'll be underneath the trim. So don't worry about it. The siding will go over it, no problem. But so we got good corners, 1, 2, 3, and 4, a bad corner which is 6, and an ugly corner which is 5 that we can live with. Okay, that's corner alignment. Okay, Tyvek covers your walls. It's what makes them waterproof. Tyvek is a synthetic plastic sheet type material. It's white. It says Tyvek on it in big letters. When you're putting Tyvek on, you don't want to go crazy with your staple gun. I would say 18 inches is about the right distance between staples when you're putting on Tyvek. The nails that you drive through your OSB will hold your Tyvek in place. You put Tyvek on before I'm trying to think. Do you put Tyvek on before or after OSB? I think the Tyvek goes on over the OSB, if I'm not badly mistaken. And your hardy board fiber cement is what is the outermost layer of the building, and it's what makes your building both fire and water resistant. Hardy board is really tough stuff. If you've got hardy board siding, you've got a really good building. It's what I wish I had on my own home. Okay, rim board. Engineered lumber. It's not simply a chunk of the tree that's been sawed from a log. It's made of consolidating a lot of wood chips together. It's heavy, it's dense, and it's dimensionally stable. And you might have a piece of rim board that is 24 feet long, but it will be reasonably good even in the middle. Now, if you had a 24-foot long piece of, say, 2x12, you might find that it's warped, or it's not really perfectly straight. But rim board is generally perfectly straight, and so it's really good. And so if you look in the plans, it's also called LVL, laminated veneer lumber. It sits on top of the cap plate. It goes around the outside of the top of the walls and around the stairway opening. So I'm going to pop into the model and show you where the rim board sits. So here we are in the model, and I have turned off almost everything. Certainly I've turned off all the second floor elements. I've turned off the subfloor. I've turned off the sidewall. Here I can flick that back on to show you how that goes. But here I've turned off the sidewall, and now we can see exactly where the rim board part of the building fits. Here's the rim wall for the rear wall. Here's two sections of rim board for the sidewall. One is I believe that this one is I want to say that this one would be the total. Trying to remember this detail. The total length of that wall, I believe, is is 36 feet. And so one is 16, and I think the other is 20 feet long. In any case, so you have rim wall that goes around the front. There's a short piece of rim wall here. There is rim board which sits above the party wall, and your floor joists will butt into and connect to the rim board. And in the part of the building which is near the front, you'll actually have triple rim boards. The red element here is called the cantilever beam, which holds up the porch. This green element is also a rim board. It's a beam. It's thicker than normal, but I believe it is also LVL. And you got a double thickness of rim board that goes along that stretches along the front here, and then you've got a single element of rim board that goes around the front and is part of the front door. Anyway, that is where the rim board fits into the building. You know, we can start turning some things back on here to see where we'll turn the rear wall on, and I think let's see, where is it? Well, anyway, we can turn things on and off. So we're talking about rim board, sits on top of the cat plate, goes around the top of the walls and around the stairway opening. We generally have floor joists sitting on top of the cat plate and nailed to the rim board. We have to use Simpson's strong tie steel hangers to attach the joist to the rim board, and this is especially true near the front door where the rim board is triple thickness, and there's no room left for the rim board to sit on top of the cat plate. So let's try and look back at the model and see that. So in the model, if we zoom in, we can see that the floor joists here are sitting directly on top of the cat plate for the first floor party wall, and so that is a very strong connection, because the floor joists are sitting there. They're not relying on the strength of a hanger to provide a mechanical connection. However, if we come around to the front of the building, you can see that we have floor joists here which are needing to connect to the rim board, the triple thickness rim board, but there's no room for those floor joists to sit on top of the cat plate. So in this particular area, for these three joists, we need to rely on a Simpson strong tie hanger to make that mechanical connection. So the stairway. The stairway is probably one of the more complicated carpentry aspects of this whole building. It's made of 3 stringers. That's the kind of zigzag cut elements. It's made of LVL, which is the same as a rim board. And you have treads and risers. The tread is where your foot goes. The risers are your vertical elements. In all the past buildings that we built, kind of before we did Esperanza in Walnut Creek, we always secured stairway to the wall studs with lag screws to make it real sturdy, But with some new rules, we have to have floating stairways, so it's reduces the noise transfer. So if you have someone tromping up the stairs, the noise doesn't transmit into the party wall and make your neighbors angry. So stairway opening is rim board. It's supported by the interior 2x4 bearing wall, and we'll show you that next in the model. But since we're reaching about the 20-minute point, I'm going to hit pause and we'll jump to a third video.